Hey, welcome to this session of Code Along with Alex. Today we are continuing our dive into Rust, and we are going to look at variable bindings. So let's just get started. Okay, I'm going to toggle to the documentation real quick, and this is the section that we're going to be covering today. There's, I guess, 4 pages we're going to be working through, but we're going to start with variable bindings, the kind of general overview page. And for those that don't recall, we are working through the Rust by example documentation. Links will be shared in the video description. So Rust provides type safety via static typing. It's great. It's annoying for newcomers sometimes, but it's great the more you get used to it. Variable bindings can be type annotated when declared. Wonderful. However, in most cases, the compiler will be able to infer the type of the variable from the context, heavily reducing the annotation burden. Splendid. And values like literals can be bound to variables using the let binding. So let's go to VS Code and do some coding instead of just running the play button in the Rust by example docs. So today I'm going to use Cargo to create a project for us to run this code. I've already created a directory in our code along repository specific for today's session. I've titled it 04 variable bindings. And then I CD'd into this directory. Now I'm going to use Cargo to create a new project. This one I'm just going to call variable bindings. And now you can see some folder or a folder and some files were created for us to run our code, which is nice. Some boilerplate to save us some time. So I'm going to remove this hello world from our main function, and I'm going to start writing some type annotated variables and some without type annotation. So actually, they're all without type annotation. So let's get going. So first, let's get an integer. It's just like a number, like 1, 2, 3, or 4. And so you can see we're declaring an integer value 1 of unsigned 32 bit depth. Next, let's create a Boolean. And we can just write true for this one. Make sure you use lowercase. Every language is a little different, so don't worry if you mess up sometimes and use the wrong case. You can always tweak your code. Next, I created a unit value, just binding to an empty kind of tuple. Cool. So next, let's copy one of our variables. So now we're just passing an integer that we defined above on line 2, and we're just copying it into a new variable called copied integer. All right, now that we've kind of created a few variables to play with, let's actually print them out to see how Rust handles and prints these different types. So we're going to use our trusty println macro. Shout out to Tiago from Edge and Node for going into an in-depth dive on Rust macros on the October 28th edition of Rust Office Hours. The Graph Developer Highlights channel is linked in my featured channel section. I strongly recommend you check out that channel for all the Rust content. It's super good. All right, so back to the println macro. Now we're going to first print out our integer, and we're going to use our trusty kind of debug formatting within the string interpolation, so we don't have to worry about a method that we haven't implemented yet. So we can just have Rust print out the debug uh, format. And it's a little uglier than you might show to a end user, but for development purposes, it's just dandy. Cool. Next, let's print out the Boolean, and we're going to use our same curly bracket with the colon question mark inside. And I'll show you what it looks like when you remove the colon bracket and the error you might receive. And then finally, let's just print out the statement, meet the unit value, and our trusty colon question mark inside the curly bracket. But this time passing our unit variable. So I'm going to save that file. Next, let's just use cargo to build and run our main.rs file. And we do that by just running cargo run. And that's because I'm not in the correct directory. So let me change directories into, I guess into the source. So, yeah. ls. Oh, that's why. Okay. So we got a cd into variable bindings. Apologies. It's early where I am. Haven't had enough caffeine yet. Okay. So now we can run cargo run. Whenever you create a cargo project, there will be a new folder created within whatever directory you are already located. So I called my project variable bindings. So there's a variable bindings folder here that I needed to change into to run the cargo command. So now if you do cargo run, you can see it's building things, stuff is happening, and some text was printed to my terminal. So we have an integer 1, a Boolean true, and meet the unit value, just the empty, I guess, tuple parentheses goodness. Cool. All right, next we can go and remove the colon question mark and see what happens. I expect to get an error, but you never know. So I removed it from the first println macro statement just for the integer. I saved the file, and now I'm going to do cargo run again. Oh, it works. Interesting, interesting. Okay. Let's do the same for each one, just out of curiosity. We're just kind of tinkering, because that's a good way to learn too. Okay, it just works, man. Interesting, interesting. And then finally, so the unit value is not friendly with the standard format display method. Yeah, that's where it hasn't implemented that yet. And so until that's implemented, you need to pass the colon question mark inside the curly bracket string interpolation goodness to basically have Rust avoid this error message and print out whatever you want it to display. So now that I re-add the colon question mark, run cargo run again, you can see that no errors. The compiler is happy. It's interesting. So not all types require that colon question mark addition. It's specifically the ones that have not implemented the standard format display method yet, but we'll likely get into that in the future. Cool. If we try to, this is another experiment I'm kind of curious about, kind of getting towards the concept of ownership in Rust. I want to print out the integer that we copied and see if it's still in scope or able to use. I'm not sure of the behavior, so I guess I'm curious. Let's go with the OG integer. Cool. And then we'll use our colon question mark. And then we'll pass an integer. And then save the file, cargo run. Interesting. What if I comment out the original copied integer print statement? Okay, I got a warning that time. I guess it wasn't used. Interesting. Okay. Maybe because it's an integer type, Rust is able to compile it into the program easily, and it doesn't have to worry about ownership. Or I guess, that's not this lesson. So let's keep going. But all right, I'm gonna now kind of, but this is good because it alluded to our next task in this file, the unused variables. Let's create some unused variables. So the convention in Rust is predominantly to prefix any unused variable with an underscore so that the compiler doesn't yell at us about having unused variables. So you can see if we now save this file, rerun it, we're good. Like nothing happens. There's no angry compiler error message. But let's create something that might not be as quiet. Save it. And then let's run this program again. And you can see this time we got some errors or a warning specifically that we have a unused variable that isn't following the underscore prefix convention. So if we prepend or prefix this name with a underscore, run the program again, no warning. So that's just something to keep in mind when you're building programs in Rust, that you're going to get warned about unused variables. So if you're kind of scoping out your logic and you're creating some empty variables that you might use later or something, Rust will probably yell at you a little bit, or not yelling because it's only yellow. It's not red. It's a warning. So it's like, hey, don't forget about these. All right. So we're done now with the first subsection of variable bindings. So let me change out of this directory back into just the parent folder. Now I'm going to toggle back to the documentation, and we're going to take a look at the next section. This one is specifically about mutability. So it's a pretty brief description, so we can get right into the coding. But variable bindings are immutable by default, but this can be overridden using the mute modifier. Awesome. So let's create another cargo project to get some practice with mutability. So I'm going to do cargo new and just call this one mutability. We're going to change into that directory. And now you can see we have the same kind of boilerplate cargo toml, source subdirectory, and then there's a main RS. So now I'm going to open the main RS in the mutability section. And let's remove the hello world boilerplate. Okay, great. First off, let's make an unused variable with the underscore prefix so that the compiler doesn't yell at us. Next, let's create a mutable variable. Same value, 1. Now we're going to use our trusty println macro to print out a statement for us to kind of keep track of the state of these variables as we apply some sort of mutation or attempt to. So first, we'll print out our mutable binding. Next, let's apply a modification to our mutable binding or mutate it. So we're just going to take our mutable binding and use the trusty plus equals syntax to add 1. This is the same as doing mutable binding equals binding plus 1, but it's kind of shorthand. So we're just adding 1 to our initial mutable binding value, and then we're going to print out the result of that mutation. So after mutation, cool. So, hey Martin, what's up? We're just doing some Rust.
Hey, Alex. Good.
Cool. How's it going?
Good. Wanted to pop in here and see what was happening.
Cool. All right.
Good.
Yeah. I'm just recording it for YouTube, so this will be a nice little fun interjection. But yeah, I'm just gonna get back into it. But yeah, we're just working through some documentation for the Rust learning community. Cool. All right, so let's see what happens when we add 1 to our variable that is allowed to change. So I'm just going to do cargo run. And you can see before mutation, the value was 1, which is what we expected. It's what we declared at the top here. And then we added 1. And as expected, the value is now 2. If we do the same operation on the variable that we didn't declare as mutable, I expect us to have an error because Rust does not let you mutate immutable variables. So let's just not even try to print out that result. Let's just see if Rust lets us add 1 to our immutable binding. So I did the plus equals syntax just for shorthand, save the file. Now let's do cargo run. And you can see we get an error message. So cannot assign twice to immutable variable, immutable binding. So the compiler is telling us we're trying to assign a value to the same immutable name twice. First, we do it on line 2, line 2, setting it to 1, which lines up with our code. And then again on line 11, it's kind of crazy how the Rust compiler is intelligent enough to just scan all this and let us know where we mess up. But basically, because we did not declare this as mutable, we can't add 1. If we now adjust our code, re-declare immutable binding as mutable, save the file, run it again, we won't get the error. Awesome. Okay, that's kind of the extent of mutability in this section of the Rust by example docs. So I'm going to toggle back to the documentation, and then we can move on to the next section. All right, so now we're working on scope and shadowing. So variable bindings have a scope and are constrained to live in a block. And a block is a collection of statements enclosed by braces or curly brackets, whatever you want to call them. So another short overview, and then variable shadowing is also allowed. So let's toggle back to VS Code and actually work through these kind of code samples that the Rust team has shared with us. So I changed back into the parent O4 variable bindings directory. Let's create a new cargo project. We'll just call it scope and shadowing. And then let's change into that directory. Okay. I'm gonna now open the main.rs file in that directory, remove the boilerplate hello world statement, and start declaring some variables. So cool. So the main function can have nested levels of kind of scope. The main kind of, I don't know, it's global, but it's kind of the longest lived binding is the main function outside of any kind of inner nesting of braces. So that would be something like this: long lived variable. And we're just using simple values like 1, like the last time. So this just is alive for the entirety of the main function. We could kind of create a nested scope inside of this that is only like a shorter time span, where anything declared inside these curly braces is only alive or active inside this curly brace. And so as soon as you're here, it is no longer active. So let's create a variable inside our kind of smaller scope or inside this block. And so we're going to call that short-lived binding, and we're going to assign it to a value of 2. And then let's print out that value using our trusty println macro. And we're not even bothering with the colon question mark debug mode because integers have the standard format display method implemented for us out of the box nicely. Cool. So you can see that we declare a variable here, print it immediately. But as soon as we leave this curly brace block, it's no longer active. So if I try to do something like this, will it work? I don't think it will, but you never know. Miracles happen. So let's try this. Actually, before I even do that, let's just see that the original one works. So I save that file, do cargo run. Okay, we got the expected unused variable message. That's fine. Can ignore that. And then inner is 2. Okay, short-lived binding. Great. So now let's try to print it outside of that short block. So I uncommented the second println statement, saving the file again. I'm gonna do cargo run again, and you can see we got some red errors. So cannot find value short-lived binding in this scope. Interesting. So it's not found inside this scope, and by this scope they mean kind of the main function, and that's because it's only valid here. And so this is kind of a roundabout way of explaining that, but it's really sometimes you want to have short-lived bindings in your app logic. So just knowing that that's a tool in your tool chest, that's nice. So however, if we'd like to print out the long-lived variable, that's available before or after this inner block. And so I replaced the second print statement with the long-lived variable. I think it's going to work, but chaos happens sometimes, so it might break. So let's see what happens. I save the file, do cargo run again. Inner 2, will it work? 1, yes. So it worked. Great. So this was kind of a a quick little example of how inner and outer kind of blocks can be structured in a Rust program. I'm just going to compress this a little bit and then comment it out so that we can do a little more code in this file. But now we're going to look at variable shadowing. And so it's kind of similar to what we did now, but it's kind of doing shallow copies in a way, I believe, of the values. So to start, let's declare a binding called shadowed binding. And we're just going to assign it to a value of 1. Next, we're going to immediately create a block. And we're going to print out the shadowed binding before it's been shadowed. Before being shadowed. So we're just trying to see what happens when we apply this quote-unquote shadow operation to a variable or to a binding. Autocomplete saves your butt sometimes, or most of the time, I'd say, from typos. Just gotta remember to use it. So then let shadowed binding equals ABC. Oh. So this binding shadows the outer one. So even though the shadowed binding was declared as 1 at the kind of main scope, inside this inner block, we're renaming or resetting the value to something else using the shadowed binding principle. So that's interesting. I could see how you could mess up your code really fast if you don't realize what you did or you forgot that you shadowed something. So I could see how you might want to use this with care. But who knows, maybe there's some really valuable use case that I'm not yet aware of. So cool. We're going to now print out the inner block shadowed binding to see if it prints out ABC. That'd be interesting. Cool. And so now we want to return outside of the inner block and print out what that shadowed binding is. Is it still ABC or is it revert to 1? What happens? I assume it's going to revert to 1, but I really don't know, man. Anything's possible these days. Okay. Interesting. Let's just try this. Let's see what happens. So before being shadowed, it's 1. Shadowed in inner block ABC. And then outside inner block is 1. That's weird. Okay. Can we assign the value after it's already been used in the main block? So let's like shadow it not in an inner block, but in the main block. So we're going to redeclare our shadowed binding to be 2 now. And then let's use our println macro. To see what the value is. I honestly don't know. I mean, we didn't declare it as mutable. Yeah, so I'm not really sure. I mean, did we? No. But maybe the let method allows us such flexibility. We're going to find out right now. Interesting. So Rust really lets you shadow variables like bindings like this. Weird. Okay. Variable shadowing. The more you know. Okay, now we can return to the Rust docs. Move on to the final section of today's, or not the final, apologies. We got 2 more sections. Let's go. So we're going to create a new cargo project, but first, let me read this blurb. It's possible to declare variable bindings first and initialize them later. However, this form is seldom used as it may lead to the use of uninitialized variables. Okay. On that note, VS Code time. I'm going to change back to the parent directory for today's session. Let's create a new cargo project. We'll call this one declare first. Let's change into declare first. Okay. Open the main.rs and let's get started. So, as usual, we'll delete the hello world boilerplate. Let's declare an empty or uninitialized variable binding. So we're just going to call it a binding. Next, let's create a block, and inside we'll create another variable binding called 2. We're gonna initialize it with the value of 2. Next, let's take our declared a binding variable and we're gonna set it equal to x times x, which in the inner block is 4. However, due to the block structure in Rust, I don't expect this value to persist outside this inner block. So when we do a print statement, the value is likely just going to be null or empty. But let's find out. My stool just slipped. There we go. Hydraulics fail sometimes when you're a big boy. All right, let's do cargo run and see what happens. It's not happy. Oh, it's because I put in a period instead of a comma. Typos happen. There we go. So, interesting. So, the a variable persisted, the value persisted outside that inner block. If I do another print statement, but try to print out x, I don't expect this to work. Let's see. Yeah, that breaks. Okay, so it's not in the scope. Interesting. So the values you assign to a variable in a nested or a block persist outside the block as long as the variable was initialized or was declared outside the block. Okay. So let's remove the second print statement and add another binding, another empty variable binding. Try to print out just this empty variable binding. I don't know. I mean, I feel like this could work. I'll try this with and without the trusty colon question mark syntax. Oh, I'm missing a exclamation point to make that a macro. Okay, save it. Cargo run. Okay, it doesn't like that. So it doesn't like that the another binding is empty. What if I add the debug format? Will it do the same thing? Yep. Interesting. Okay. So it really wants a type. Okay. What if I just do that? I'm going to take this out in a second, but like, nah. Okay. Well, let's take or another binding value and just set it equals to 1. And then rerun our program with the print statement below that addition operator or that initialization step. So do cargo run again, and this time another binding is 1. We're not getting an error about having an uninitialized variable. Splendid. So pro tip, the compiler forbids use of uninitialized variables as this would lead to undefined behavior. Okay, now we are moving on to our final section for Rust by example today. So I'm going to toggle back to the documentation. Now we're moving on to freezing. So when data is bound by the same name immutably, it also freezes. And frozen data can't be modified until the immutable binding goes out of scope. So we've got another short little section here, but let's toggle back to VS Code and just dive in. So change back to the parent directory. Use cargo to create a project called freezing. Change into freezing. Open source main RS. Delete the boilerplate hello world and get going. Cool. So we're initializing a mutable binding. Looks like we might not use it though because we're prefixing it with an underscore, initializing it to be an integer 32. Next, we're going to create a block. We're going to create another. Ooh, we're going to shadow our mutable integer. Shadowing by immutable integer. Interesting. So let mutable integer equals mutable integer. Weird. So if we try to now update this immutable integer inside this block, I expect us to get an error. Even though it was declared as mutable in the main scope, inside this kind of block, it is declared as immutable. So that's tricky, but it makes sense. But I can see how you can get tripped up and run into issues. So let's run this and see what happens. I mean, I expect it to break, but you never know. Miracles happen. Yeah, red. Okay, so cannot assign twice to immutable variable. Yeah, so we here declared it or shadowed it as immutable and then tried to assign it again. It's not happy. It's not happy. Okay, so let's comment this out. Let's exit the scope and see what happens. So this is only like a temporary immutability status. As soon as you leave this brace block, technically mutable integer is mutable again. All right, so let's set our mutable integer to 3. And then let's just print it out because it's fun to print things. What is the value? Okay. I mean, I'd wager to say the value is 3, but you never know. So I save the file. Gonna do cargo run. I expect it to print out 3. I guess before I do that, so we have a mutable integer up here, so I expect that to be 7. And then it'll print out 3. Let's hope it works. What is the value? 7. What is the value? 3. Awesome. Okay. I mean, that was expected behavior. Makes sense. On that note, if we toggle back to the documentation, we can see we have finished variable bindings. So on that note, I want to say thank you for hanging out today. I really appreciate your company and joining this small learning community. New videos every Saturday, but if you want to join live, just sign up on the Graph Advocates DAO Discord and just join an event. It's open to the public. Don't have to be an advocate, but feel free to join the program too. On that note, this was Code Along with Alex. Have a great day. Thanks. See ya.